Okay, hi everyone. We are here for another Wolfram Language design review for version 14.3, and we're talking about chemistry here. So I'm kind of hoping that a bunch of the things that you guys have built that have been in the function repository in recent versions are now moving into the system context. Is that true or not?
That is not true today. We should have a meeting where we all go, we show them to you and you tell us which ones.
No, I think you guys should make proposals for that. I
Okay.
mean, the goal is to have these things, you built a bunch of stuff that went in the function repository just as a matter of speed. But, we kind of need these things to, in the end, they should be in the system context and as system functions.
Okay. One of the contributions today is that case, Stephen. The invert atom WFR was made part of Molecule Modify.
Okay. How do I get, so here's a simple question. I mean, we've got biomolecular plot 3D, biomolecular plot 3D. How do I get the coordinates for, how do I fold a protein and get its coordinates out?
So the property is called atom coordinates.
But property
So
of
once you
what? I mean, how do I do the folding?
right, so let's see. If you look at the ESM Atlas documentation page, there's
No,
some examples
no,
there.
no, no. That's not what I'm looking for. I mean, I'm looking
Okay.
for a function that does that. It's a thing people want to do. Why don't we have a function that does it?
So biomolecule of a biosequence calls out and folds that and returns
I
a
see.
biomolecule with coordinates.
Okay, okay, fine, fine. Okay, so
It
that's the
calls the
answer.
service connection under the hood.
Okay, I don't care. I mean, the main point is that there's a system level way to do that. And is that well documented?
Yes, I believe there are lots of examples.
No. Because this says, okay, well, that's not bad. Why does it have, okay, power sequence? That's not bad. That's actually pretty good. Um, okay, I retract my complaints. That's pretty good, what it says there. Um, okay, all right. Let's get going here, looking at the things you want to look at. All right, what's first?
So in the molecule modify documentation page, there's a new modification called invert atom with several examples. And so it's a large page. You have to search for the word invert atom.
Well,
But it's under geometry modifications here. One more down. There we go.
I don't know why the A isn't italicized there, but that's a very small point.
No, that's a good point. Or yeah, I missed that.
Okay, I haven't a clue what this does. I mean, this is an inversion, this is a space inversion of the coordinates around that atom.
Not quite. What it does is it inverts the stereochemistry at selected atoms by geometrically moving ligands that are free to move without damaging the rest of the geometry of the molecule. In other words, they're not restricted by bonds back to the rest of the molecule, basically. It's a common need for people doing drug design and things like that, where they need to change the position of a ligand from, let's say, being up to being down relative to the rest of the structure.
Why is it called invert atom? I mean, I would have assumed that was some kind of space
Uh,
inversion parity transformation or something.
Because the stereochemistry at that position gets inverted from R to S or S to R.
But why is it inverting the atom as opposed to inverting
To the
stereochemistry
invert
or something?
around atom, but
Well, it's inverting
Okay, the
stereochemistry
short the
around.
short answer is that's the way I wrote it back in the 1980s when I was at Merck, and I've rewritten it entirely in Wolfram language so we could have it in our system. So I just
Okay.
carried the name over that we used back then.
Have other people used similar names in the intervening years or not?
Generally, for molecular modeling packages, that's the way things got named often. Some of them were even more bizarre or cutesy. acronym based and things like that. I never went that way. But
Okay, but I mean, it's not inverting the atom, it's inverting the bonds, right?
um, positions of many atoms do move. It's not an inversion operation, a geometric inversion operation, but it does do what I had said is it inverts the stereochemistry at a given position, and that's why it has the verb invert, and it does it at a specific atom rather than the whole molecule.
Well, maybe invert atom geometry or something.
Well, it would be more invert stereochemistry, right? Or
Uh,
something like that. Or
it's it's a
invert
it,
stereo?
it's a geometric operation, um, and you don't say you don't think of it as the topological inversion from R to S or S to R. It's a geometric operation that's carried out to accomplish it.
Let me see. Invert atom. Here we go.
As a side note, one of the big uses of this was Amaya's project from the WSRP summer group last summer. So in that
That
case, invert
that
atom
ex
worked really well for the student. They didn't, I mean, they got it right away with the name, but arguably they may not be the target audience.
Yeah, that example is actually in the documentation, Jason, but in the
But
reverse
hold on.
direction.
What is this? What is going on here?
Okay, well, okay. Because of the way molecule plot 3D orients the initial view, it's a little bit hard to see what's actually happening. But what it does is I'm asking it to invert the carbon that has the hydroxyl group on it, the red oxygen atom. And it looks at the structure. It determines that there are two positions that can be changed. Um, the hydrogen and the hydroxyl group. It essentially bisects the CCC angle in the other direction and then rotates the moving groups around that axis to accomplish it in this particular case. Um, I did not want to burden the example with additional molecule aligns to make it more obvious about what was happening. But one can see if you want to use, the 3D, well, these are probably rasterized already. But if you reevaluate them, then you can rotate the molecules and see that the orientation of the hydroxyl group has changed.
I mean, it might work well to just give it the option like viewpoint goes to front on both of them or something like that.
Okay, we can try that. Yeah. So there, the bottom one, the oxygen atom is pointing back away from you. And if you take the top one and roll it a little bit so that the backbone has the same
I'm
scroll.
pretty definitively confused here. I mean, and this example is deeply confusing.
Okay, we'll have to fix it so that the orientation is more clear about what's actually happening.
I still don't understand it.
I mean,
Maybe try going down. Maybe Amaya's example might be helpful. The K joint.
scroll down some more. It should be there. Next one. We've moved on to. I can't quite read everything. It's too small on my monitor. Um,
Okay, I don't understand this operation at all. Okay, just saying, I don't understand it at all.
if I could share my screen, I could show you what was happening.
Go ahead and start a share.
Okay. Let me just make sure that I've got.
Yeah, make sure you have a clean screen.
Yeah.
Or send me a screenshot of something if you want to. Okay, look, I don't understand this operation, so
Okay, we'll clean it
I
up.
can't name it, if you don't understand what on earth it is.
Yeah.
It's
Okay, I'm getting 14.3 launched. I didn't have it
Okay.
loaded.
I mean, is it invert around atom or something?
That might be a better name for it, for the exact operation that's happening. Yes.
Yes, because that's what you do is you select an atom and then you tell it to invert
Invert at atom?
Mhm.
Okay, I'm sharing my screen. Where are we?
Bob, you might need to enable dynamics above.
Yeah, thank you. Okay.
Well, I'm not seeing your screen share, so I don't see
Okay,
it.
I've got green around my window.
So I see it.
I see it too.
Okay, I've
So
just evaluated the two cells. So
Okay,
if,
all right, okay. No, I'm not
okay.
seeing your screen either. There we go.
Oh,
No, I am.
By
No,
chance,
I
is
am.
it on a different window, Stephen?
Yeah, no, I am.
well, I mean, one thing I find is that if I show percent and percent, then they are aligned together, and you have these overlaying. Um, most of the geometry
yes.
overlays.
Just show mol, comma, invol. Show, yeah, mol, comma, invol, mol.
Well, hold on. I mean, mol is into graphics 3D, graphics or graphics 3D.
What
So
is
if you just show molecule plot 3D at
Yeah,
mol,
yeah, 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 yeah. Yeah, just a second. Okay. And now you
right?
can see that everything is the same except the groups that moved. All the rest of the structure is unchanged, which is important from a molecular design point of view. And basically what happens is that you construct an axis coming out of this atom that bisects the groups that are moving and just do a
How do you know
twofold
which groups are
rotation.
moving?
You look at the structure and you take the two smallest groups that are free to move that don't have any bonds back to anything else. So it looks at the adjacency matrix and analyzes that in a sophisticated way to know what's able to move. If I asked it to invert an atom that was bound all the way around into
So why don't we call
rings,
it invert movable atoms? Is that the right name for it?
Well, it's accurate. It's just
it,
long.
yeah,
I don't
but
care that it's long. Is it right? Invert movable atoms?
um,
So it doesn't say which ones you're moving. Like so
that,
No, no,
yeah,
here,
that's just it.
but you're going to give the atom that you're moving relative to which you're
Well,
moving.
we give the position at which where we want the operation to occur. That's important. We're not
Yeah,
telling
well,
it these and those.
so I liked invert around atom.
I don't know
Yeah.
because you're talking about movable atoms. That's a whole other level of complexity of what's going on.
Well, that's the way it's accomplished. I mean, when we uh, take a molecule that does not have any 3D geometry and we say, give it coordinates, we don't talk about doing distance geometry, which is what actually happens in the background.
Bob?
I don't get the point there. I mean, the point is that there are atoms that are movable.
Yeah,
True or not true?
it's true.
Okay, so why is it not invert movable atoms? You're inverting the atoms that are movable, not the atom that isn't movable, that you're not moving, that's at the center.
Okay.
Hey,
Point
Bob,
taken.
have the CIP rules changed? Or would the CIP rules change the stereochemistry at the atom that you're moving at?
Yes. In fact, that's shown right here that it goes from R to S.
Does that always hold? Because then it could be invert stereo atoms or inverts.
Okay, for whatever reason, you might not want to invert something that is an actual stereo center, and it will blithely go ahead and do the same operation, for example, on this atom here, and exchange those two hydrogen atoms, even though it might not change the
Which
stereochemistry.
correct. I see.
So I did not want to tie it to stereochemistry, although that is one of the main reasons that it's used. Okay, the other example that you were asking about, Jason, and Jason Biggs, I think we need to clean this up. This was left in inadvertently.
Yeah, noted.
That line there.
Yeah, there we are. Down by the cages.
Here, this one here. Jason's summer school student had this structure.
Yes. Okay, so
I'm
look,
sorry.
we can't spend more time on this. Okay, the issue is only, the name for this thing. Invert atom is just not a reasonable name. It's incomprehensible.
I think invert around atom makes it really clear what it does.
Okay, I'm okay with that.
Yeah. Okay, this example here, Jason's student, when she constructed the geometry, it came out this way with a hydrogen pointing inside, and doing the inversion operation, flipped it around so that it was pointing outwards now, where it's much more reasonable and sterically uncongested. This operation isn't
All
done
right,
by a rotation, but by actually finding an appropriate plane and inverting the
all right. So invert around
yeah.
atom is where we're going with what we're going with.
Yeah, we can make that work, and we'll fix up these examples so it's more clear what's happening geometrically.
Okay. All right. Why don't you unshare and hopefully my
Yeah.
screen will share again.
It is. We can see your, or at least I can see your screen.
Okay. Two new service connections. Okay. Biomolecule align. I mean, so are we using those service connections for anything by default?
Let's see, if you give a particular type of a external identifier to biomolecule, then we'll call the AlphaFold database to look it up.
Okay. And is that an external reference type thing that we're using for the identifier or what?
Yeah. So the external identifier, what was it, Sutik?
Uniprot knowledge base, so that's called Uniprot KB accession number is the name of the identifier. So yeah, that's one of the most comprehensive database for protein sequences.
And something like
How am I going
70%.
to find this? Where is this?
Right. So there's services is one of those guys.
Where is that?
Trying to.
This needs to be in alphabetical
Other
order.
and then service pages.
I'm looking at other.
Yeah,
It
and
needs
then
to be in alphabetical order.
yeah, device under device pages. Yeah, and then get service page. Yeah, and just the name AlphaFold data, or yeah, P should be, yeah, it's fine.
We have to specify Uniprot ID like this, and this is the.
So it's showing that you can give either the string or use the external identifier wrapper.
And I guess if you just search for biomolecule of that ID, you will get the biomolecule at this point, right, Jason?
Oh, I haven't set that up yet, but that
Oh,
will.
okay, yeah.
And so that will call AlphaFold database. So Uniprot just houses sequences, and something like 70% of the sequences there have been sequenced by AlphaFold and are stored in their database.
Yeah.
Is that correct, Sutik?
Yes, most of the AlphaFold database protein structures, it covers most of the Uniprot. So yeah, so.
Okay. Well, where's the alignment? And sorry, where's the folding? Is it in?
Oh, yeah, if you go to, there's a request called Biomolecule just
No,
under
but
this.
predicted structure details should surely have the positions of molecules, not the error plot. The error plot is much less important than the positions of molecules.
Yeah,
Am I making sense?
it's there. Yeah, it's a separate request, but I can also include it in this database if that
Well, but
helps.
what is the request? Because I mean, I don't understand why that wouldn't be the thing you would show first. That seems like the most relevant thing.
Oh, in the
I mean,
doc
it's
page, I
not,
can show you.
seeing the error terms is much less relevant than seeing the
Yeah,
actual
that's true.
result.
Yeah, that I can give as the first example then.
Yeah, I would think so.
Yeah, that's
I
fine.
mean,
Yeah.
so give me a so if I take this
So
here,
yeah.
so what are you telling me? That I
So
have to do this
just
whole rigmarole, or what can I do if I just do the
biomolecule, string of biomolecule at the beginning. So that's the request. Sorry. Yeah.
obviously you should have given that as the first example.
Yeah, and then the whole thing, Uniprot ID goes to that.
Why do I need that? Why do I need that? You know what this, or I mean, isn't that going to be a molecule identifier as a second argument?
Well, so the what do you call it? The syntax for service connections is pretty set. That the first you give the name of the request and then the
Okay.
options.
So now what should happen here is if I just say biomolecule of, then the external identifier for this thing, right?
Right, and that
Yeah.
will be set up.
Yeah.
Okay. All right. Okay.
There's one thing that I wanted to note. I made a tentative note on the biomolecule and molecule documentation pages that when you do biomolecule of an external identifier, the data will usually be cached in $temporary directory. It's something that I really find useful.
Is that the right way to do caching as opposed to in a local object store? What is the generic way that we do caching?
I'm not aware of
Okay,
that.
you can't make up your own version of how to do this.
I got this idea speaking to Sean Charon. This is how he's doing it with external storage connector or data connector.
Please send out mail to a more general list and ask how people are doing this, okay? Because there are all kinds of caches that we have, and they should be handled consistently. And I think they're mostly handled in the local object store.
But how does a user know how to delete that stuff? I guess my thought is with the temporary directory, it will automatically get deleted.
Do you want it deleted? I mean, is that molecule going away?
Let's see. So as of now, it gets re-downloaded every time you call it.
I understand that. I'm asking the question. Once you've downloaded a molecule once, you go to another session. Do you really want that molecule to go away between sessions?
So I don't, but I don't want a big pile of these
we've got a
files
whole
taking up a
mechanism.
bunch of
That's
space.
why you should use the same mechanism as we're using for every other cache. Okay? Because that issue comes up with every kind of cache. And we've got a central way to do this.
What else caches then, I guess, who I can talk to about
every
this?
Packlet, every data packlet caches. Every single thing. Okay? Basically, any external information is cached. Every Packlet, every function repository, function, all those things cache. Okay, so please, but what is it? You're caching molecular coordinates. Is that correct?
Right, like so in this, like the PDB file that you download when you call one of these services, you would store that PDB file locally.
Yeah, okay, that's the same kind of caching that's done for every old data packlet. Right, so please ask if nobody else, Alan certainly would be able to tell you who to ask.
Is this related to persistent objects, Stephen?
Not really.
No, okay. Because I just tried, object store in the documentation, and I'm not seeing anything come up that looks close to what you're describing.
What we're doing, it is the internal way that Packlets are cached. Okay?
Okay.
Please use that mechanism. Do not invent your own mechanism. Please don't do that. Please don't do that.
All right, but specifically, I was not inventing my own. I was talking to Sean, and he
Yeah, okay, well,
came
he
up
has
with
a
his.
different
And
set of requirements. He is dealing with things which are ephemeral. You're dealing with molecules which better not change in the history of the world, right? His stuff
right,
is data you're downloading once, different from typical things in data packlets. Okay, anyway, you'll get this sorted out. Just use the mechanism we're using for everything else. And there's some standard piece of code that does the caching, which you can use. Okay, let's look at biomolecular align. What is this for?
let's see. One of the main uses is, let's see, you've got some known experimental structure, and you have some other sequence that is similar to it, but not exactly the same, and you've
Okay, you
predicted
know
a
what?
structure.
If this is a system function, do not use service execute in its examples. Certainly not at the beginning. Okay, you don't need that. If you need to, put that either as example data or actually put it as an iconized object here. See what I'm saying?
Sure. I mean, in this case, I could actually do biomolecule of
Yeah, so
the
why are you
second
using
one.
service execute here? Well, the very first example, you're leading people into this whole complicated zoo of nonsense.
Okay.
They don't do it. I mean,
Yep.
Yeah, I mean, that should be part of our instructions for writing documentation. Don't ever do something like this, right? Because you're trying to document a function that is, we're not even getting to the function you're documenting yet, right? You got to not have, somebody's looking at this page, they want to know how to use biomolecule align, and I don't know why you're putting these on the same line. That's again it does not follow the instructions that we have, right? The instructions we have say, don't put these things together.
Right. Okay. So then in this example, like I should say, create a molecule that is a biomolecule that's your experimental, and then it produces it, and then create a biomolecule that is predicted off of the same sequence, and then do that, and then show them together. I guess I wanted to elide those inputs that were just going to return a
That's fine,
biomolecule.
but then so figure out a better way to do it. I mean, look, okay, ask other people how to do this. Okay, I'm not the right person to ask. Bob, do you know how to do this?
The documentation aspect?
Yes.
I have seen no formal written instructions on documentation. Are they hidden
Right,
inside of
okay.
DocuTools somewhere? I
No.
basically follow precedent from the already written documentation and
Okay,
try to
fine. Well,
follow that.
okay, but this isn't that. So,
Okay,
okay.
I
But what
understand
does
your
this
point,
function do? What does this function do?
So
Jason.
it takes one biomolecule and aligns it to a reference, and then returns either that biomolecule, which has been rotated and translated in space, or it can
That's its
return
default.
information. Yeah,
That's its default, right?
or it can return information about the alignment.
But by the way, since we use biomolecule with internal capitalization, you should use biospace molecule here.
Okay.
So the default is to return the realigned biomolecule, correct?
Mm-hmm.
Yes.
It's very much like molecule align in that respect.
Okay. Residue labels for biomolecule plot 3D.
So I haven't added it to this page yet. And actually,
So
residue
let
labels
me
didn't get
see
into the
here.
prototype fast enough, so the
But
examples on that
is
page
this
don't work.
so that's another symbol, right?
Yes.
Okay. Along
And
with
so
include waters, and it's residue labels arrow automatic will do something, and then what is residue labels arrow, and does it work like a graph? How do you specify which residue you're labeling?
So at the moment, you either label them all or not, and it's done. So this one is kind of odd compared to all the other labeling things because you're labeling so many things that it's only in tooltips or status area. We don't even try to do them in space or on the graphics.
Well, if you were picking only a few, you might want them on the graphic.
Right, but I don't know how to put them there in a good way.
Well, what about using the same mechanism as in graph?
Vertices are infinitely small in a graph object, so there's no interference. You only have the edges to dodge. And with a biomolecule or molecule, you've got spheres for atoms, you've got cylinders for bonds, and it's very challenging to find positions to place atom labels or residue labels where they're not occluded or eclipsed entirely.
Okay, so give me an example here. What example can I use to see this? Can I use?
Well, so let's see. So right now it does not work because it didn't make it into the prototype, but there are a couple of examples on the residue labels page.
Well, what the hell am I seeing here?
So it should
Wait,
show
wait,
up
wait,
as
wait. You changed. See, again. Don't do this. Don't change two things at once, right? You should show the labels on this one. Don't change to it, because I can't tell what's happening here. See what I'm saying?
well. So the only, I mean, in both of those, it does show the labels, or it has the labels as tooltips.
Oh, I see. Okay. Sorry, I didn't see that. Okay. Well, they're not showing up as tooltips for me. Oh, I see there. What does the colon mean?
It's just a separator.
Between the chain and the residue.
Yeah.
It's residue 8. What good does that do me? It's numerical residues? I don't understand.
It's the
So you
standard.
can, well,
Go ahead.
let's see, there are a couple of different properties that you can use for labeling them. There's the residue index, which is its position in the list of residues in the biomolecule. There's also, they've got a residue ID, which is oftentimes the same as the index, but sometimes it's not. It's basically the ID of the residue in the reference sequence, whereas we don't have, let's see, oftentimes you don't have all of the residues in your crystal structure. And so sometimes the ID number and the index number are different. So you've got the option to do either. Yeah.
And they're labeled sequentially, starting from the N terminus of the protein chain to the C terminus. It's standard notation that's been used by protein chemists for decades.
Okay, but in all cases, it's just a tooltip. Is that right?
Or a status area. Yeah.
Well, how do you say which?
So placed, and then the specification, and then
Is that
status area.
standard?
Yes.
Okay. I mean, is that standard, that mechanism for placed? Is that a standard thing for placed?
Yes, that is. So that's how Graph does it in molecule plot.
Okay, all right, fine. I haven't used that. Humph. So the default placed. Again, is that really the terminology we use? Mousing over?
I do not know. I came up with that.
Okay, so I know, but you got to kind of, okay. Well, I get it. I think this is as reasonable as it's going to get. Okay. Anything else we need to go over in this review?
No, that's what we've got.
Okay. Now, I mean, the chemistry WFRs, of which there are many and some really wonderful ones, we need to figure out how those make it to, into the main system.
Right. So I would like to, in this next release cycle, then have some meetings earlier with you,
Well,
where
I thought we kind of talked about the so is there a chemistry section here yet? That was supposed to get put in.
Not yet, but if you search for chemistry, the search has gotten better.
There's a ton of stuff here that really needs to be. I mean, this is not, this was done.
There's chemistry stuff here, and there's a lot of stuff that's very peripheral to chemistry. I've spoken to the function repository people about it. They prefer to err on the side of excess rather than keep it more
No, that's
focused.
fine, but I'm just yeah, I mean, look, we just need a plan to get all kinds of nice things that you've built as actual system functions. Which means that their design has to be a little bit more rigorously handled.
Right.
Jason B., let's make a list at our next biweekly meeting of the WFRs that we think would be reasonable to pull in, and if there are any that might be combined or grouped or whatever, or something like that, and come up with an overall design for bringing in a bunch of the functions, and we can work on that in the next release cycle.
Yep,
That'd be
that
great.
sounds good.
Good.
Okay. And then I'd probably begin by specking out what the documentation examples might look like to deal with some of these issues that come up in these reviews sooner instead of later.
Also, what happened to the crystallography stuff? Crystals.
Right. So I have like I made a prototype packlet of a crystal structure object, and then I realized that I don't know nearly as much. So there's a packlet repository produced by an external guy called MaxRD that is far and above what his knowledge in crystallography is way more than mine.
Yeah. His the application focus is more on solid state physics in crystals. I would prefer something more toward organic molecules, and I need to play with that packlet more to see if it is able to do the things I'm used to doing in the past with structures from the Cambridge database.
Yeah, right. Okay, sounds good. All right. Well, I think we can.
The other thing that we were thinking collectively is that it's good that we have somebody external that's building just as powerful stuff as we are too. So
yes, absolutely, that's wonderful. Okay, I think we can wrap up the main part of this review. I'd like to continue a couple of administrative things. So, bye to everyone.